So in this video, we're going to solve the following problems for x by using the quadratic formula. Right, so here's my function, right? 0 equals 2x squared minus x minus 5. And again, the first step, we want to make sure we're in standard form, which we are, right? This is in the form of 0 equals ax squared plus bx plus c. So we can now start identifying the parts a, b, and c. Right, again, this is what our standard form looks like. Here we've identified our a, our b is -1, and our c is -5. And we're going to substitute these values for a, b, and c into our quadratic formula. So once we substitute our values, we have something that looks like this. And now we're going to want to enter this into our calculator just the way it's written. So here's my calculator, and you'll notice I typed it exactly as it's written with all of the parentheses, right? And we're going to start with the plus sign first. I press enter. So I get 1.85078. And then I want to get the negative version, right? Because remember, this does say plus or minus, so we want to try the minus part. So I press second, and I press enter. It brings up the last thing we did, right? Here's that divided by 2 times 2. And I'm just going to press the left arrow to change the plus sign to a minus sign. So here it is. All right, so now we have the minus case, right? Plus, minus. I press enter. And we're left with -1.35078. So let's just round 2 decimal places, and I'll write my answer down here. So here's my answer. X equals 1.85, and x equals -1.35. And again, that's what matches what we have in our calculator. So now what if we want to solve this equation graphically? Well, we can graph both sides of the equation. Remember, this was the original equation, this 0 equals 2x squared minus x minus 5. So I'm going to graph y1 equals 0, and I'll graph y2 as the 2x squared minus x minus 5. And let's just try a standard window, or maybe slightly bigger than standard. I'll say -15 to 15. And I think I'll do the same for my y-min and y-max. Okay, so let's see if we see the intersection. All right, so here's y equals 0. That's this blue line. And on the right side, the 2x squared minus x minus 5 is the red line. And the intersection is what we're looking for. So I press second and trace number 5 for intersection. And I press the enter, enter, enter. And it says my intersection happens at -1.35, which is what we found down here, -1.35 as one of our solutions. And then the second solution, if I press second, trace again, number 5, I press enter, enter. But now when it says guess, I already know this answer. So let's move the cursor to the other side where I think my second answer will be found. I press enter, and I get 1.85, which again matches what we have down here. So we've solved this problem twice, once by using the quadratic formula and once by graphing. Okay, so we're going to try and solve another problem using the quadratic formula and then by graphing. So we're given 8x squared equals 3 minus 10x. Now remember, standard form is this 0 equals ax squared plus bx plus c. So we have to rewrite this equation. We have to put this into standard form. So we're going to want to subtract 3 from both sides of this equal sign, and then we're going to add 10x to both sides of the equal sign. And our new equation will look like this. Right, essentially we've just moved the 3 over, but now it becomes negative, and we've moved the -10x over, and now it becomes positive 10x. And now this is considered standard form, right? We have 0 equals ax squared plus bx plus c, and maybe I should even rearrange this order. I think this looks better. Right? The order doesn't matter, right? Whether I have the 10x first or last, but I want to kind of stay in this form, right? ax squared plus bx plus c. So you can see my a is the 8, my b is the 10, and my c is the -3. So in this line 3, I've identified my A, my B, and my C. So we just need to substitute this into the quadratic formula. So when we substitute these values into our quadratic formula, we have something that looks like this. So let's enter this into our calculator directly as we see it. So here's the equation entered into my calculator. Again, I took very great care to make sure I enter all of the parentheses in the right places. I press enter, and you see I have x equals 0.25. That's for the plus case. Now we have to handle the minus case. So I press second and enter, and it brings up the last thing I did. And now all I need to do is arrow over and change the plus sign to a minus sign. And then I press enter. So I have negative 1.5 as my second solution. So I'll write down my two solutions here, right? X equals 0.25 and x equals negative 1.5 are my two solutions. So now let's verify this graphically. Okay, so we can graph both sides of our equation. Right, this was my original equation, the 8x squared equals 3 minus 10x. So we could actually graph both sides of this equation, right? We could graph y1 is 8x squared and y2 is 3 minus 10x. Or we could graph 8x squared plus 10x minus 3 as y1 and 0 for y2. So that's what I'm going to do. Okay, so I press y equals, and then I start entering the 8x squared. So here's 8x squared plus 10x minus 3, and then y2 will be 0. And we'll check out our window. All right, we'll try and use this window. Hopefully it still works. I press graph. And there's my first curve. Right, that's the 8x squared plus 10x minus 3. And then this is the 0. And if I press second and trace, number 5 for intersection, right, we press enter 3 times, and that gives us the intersection on the right, which is the x equals 0.25, and that matches up with what we found here, right, x equals 0.25. And we know what the second answer is. We know it's going to be that 1.5 negative, right? So just to verify, press second, trace, number 5, enter 2 times, and now when it says guess, well, we already know this answer, so I'm going to move the cursor to the left a bit and press enter. And we get x equals negative 1.5, which is what we found using the quadratic formula. Right? So we've solved this equation here for x 2 ways. We use the quadratic formula, and then we solve by graphing.